This episode of Science Scout takes it to the next level. Have you ever seen ocean currents, waves, or tides? Maybe you saw them when you were near the ocean, or in a movie, or those surfing sports commonly shown on sports channels. Let me tell you something you may have never heard before. Those ocean currents, tides, and waves represent an enormous amount of potential energy waiting to be harvested. According to the Electric Power Research Institute, EPRI, the total available wave energy resource along the U.S. continental shelf edge as of 2011 is approximately 2,640 terawatt-hours per year. This value is higher than the 2004 estimate of 2,100 terawatt-hours per year. Well, the reason for this 26% increase was because the 2011 estimate considered the full range of U.S. coastal exposures, unlike the 2004 estimate. EPRI further reported that the recoverable wave energy resource along the U.S. shelf edge is 1,170 terawatt-hours per year. This includes 250 terawatt-hours per year in the West Coast, 160 terawatt-hours per year in the East Coast, 60 terawatt-hours per year in the Gulf of Mexico, 620 terawatt-hours per year in Alaska, 80 terawatt-hours per year in Hawaii, and 20 terawatt-hours per year in Puerto Rico. To appreciate these statistics, let's consider the U.S. annual energy consumption. As of the end of 2019, the total U.S. consumption of electricity was 3,990 terawatt-hours per year. This means if the U.S. recoverable wave energy of 1,170 terawatt-hours per year can be harvested, it will supply more than one-third of the U.S. current yearly energy consumption. Isn't that great? You may be wondering why we are currently not harnessing these wave energies to better our daily activities and society. Well, the issue is complex. First, tidal energy systems are quite costly to install. Also, it is quite challenging to harness ocean energies without affecting the local ecosystems. However, the fact remains that if we can find a suitable way to harvest these energies off our coasts, it would convert our power grid to a reliable and renewable energy source and greatly reduce the cost of electricity consumption. Let's go a bit deeper into ocean lives. Have you ever wondered how ocean currents, waves, and tides come into existence? Well, these complex phenomena are caused by wind, heat from the sun, the bottom topography of water bodies, the Earth's rotation, and the salinity of the water. The differences in salinity between rivers and seas have been used by some systems to produce electricity. There are many methods to gain energy from the ocean and other large water bodies. We only need to make use of the methods that will ensure the safety of our aquatic ecosystem and the human surroundings. In this video, we will examine the most promising technologies which are utilizing tidal energy. These technologies are highly promising in the aspect of renewable energies. This is largely because tides are predictable and consistently available. Tides change 4 times every day, and they all involve the rise and fall of sea levels. They vary according to the lunar, solar, and atmospheric forces at work. Based on the forces involved, there are 3 basic types of daily tides. However, a 4th type exists, which encompasses atmospheric variations. The first one is diurnal tide. This one has 1 episode each of high water and low water every day. They usually occur when the moon is farthest from the equator. The second type of tide, semi-diurnal tide, is the most common. It has 2 episodes of equal high water and 2 episodes of low equal water each day. The second high tide rises to the same level it did in the first high tide. Similarly, the second low tide falls to the same level it did in the first low tide. Semi-diurnal tide usually occurs when the moon is directly over the equator. Mixed tide, the third type of tide, can have 2 episodes of high water and 2 episodes of low water per day. However, these episodes do not rise and fall to the same levels. Mixed tides will happen when the moon is extremely far north or south of the equator. These 3 tides are astronomical tides, which means they are influenced by gravitational actions of the sun, moon, and Earth. The 4th tide, meteorological tide, is atmospherically influenced. This means it is caused by wind, barometric pressures, rainfall, ice melting, and land drying. An example is a storm surge that results in a dramatic increase in sea levels. Despite the availability of tides and the enormous energy associated with them, ocean power currently represents a small portion of our renewable energy. Let's look at how the tidal energy system works. The system consists of three major components, which include the turbines, the generator, and the transmission line. The tidal turbines are designed to be rotated by ocean tides until a wave height threshold is reached. However, newer turbines, such as the AR2000, is designed such that in situations with high waves and flows, the turbine only reduces its power setting and reduces its loading. These high waves are not common and only occur 2 to 3 times a year. As the turbine rotates, it converts the kinetic energy of tides into mechanical energy. The mechanical energy is then transferred to a generator, which causes an interaction between the copper wire coils and the electromagnets of the rotor to generate an electric current. This current is then transmitted through the transmission line to the offshore facility from where it can be distributed for use. Tidal energy systems are a long-lasting and reliable source of renewable energy. However, presently, there are only a few of them around the world due to the cost of their installation. Its alternatives, such as solar and wind, are far cheaper. For example, in Canada, it was estimated that tidal energy would cost 66 Canadian cents per kilowatt hour, compared to wind energy that usually costs between 20 and 30 Canadian cents. The Siwa Tidal Power Station in South Korea is the largest and most expensive tidal system in the world. It cost $298 million to build in 2011. The Lorentz Tidal Power Station in France was built in 1966 and is the oldest tidal power station. It cost $115 million at the time of construction. This cost is equivalent to $918 million in 2019. Though tidal systems are costly to install, the fact remains that they are a very predictable, renewable, and sustainable source of energy. For example, the Lorentz Tidal Power Station is 54 years old in March 2020. Despite this, it is still producing energy at its full capacity with no end in sight. This is unlike wind turbines, which have a lifespan of around 20 years. Different renewable energy companies around the world have been doing great works in the development of tidal systems. One such company is Alstom. Alstom is one of the leaders in development of renewable and sustainable energy in the world. The company first developed a 1 megawatt tidal turbine, which was deployed in 2013 as part of the REDAPT project. This project was successful. This inspired the company to develop another tidal stream turbine called Ocead 18. This turbine has a 22-meter long nacelle and a rotor with a diameter of 18 meters. It weighs 150 tons and can generate up to 1.4 megawatts of power. Ocead 18 rotates to face the incoming tide at an optimal angle. This allows for the extraction of the maximum energy potential. The turbine has 3 variable pitching blades and is equipped with plug-and-play modules on rails. The modules are accessible through an inspection hatch at the rear of the nacelle. This allows for faster assembling and maintenance. The turbines of Ocead 18 are buoyant, making it easy to tow to and from the operating site. Also, the buoyancy means there won't be a need for any divers or special vessels for installation and maintenance. This dramatically reduces costs. Alstom reported they would install 4 Ocead 18 tidal turbines at the Ras Blanchard pilot tidal farm by 2017. With that, they would be able to produce 5.6 megawatts of power that would supply power to approximately 15,000 people. The project is expected to operate for at least 20 years. That would go a long way to reduce the price of electricity consumption in society. Up to date, Alstom is continuing to develop solutions in the field of renewable energies. Another company doing a great job in the field of tidal energy production is Andritz Hydro Hammerfest. In December 2011, the company cooperated with Scottish Power Renewables to install its prototype 1 megawatt HS1000 tidal turbine at the Falls of Warness in Orkney Isles, UK. HS1000 is a fully submerged, variable pitch turbine. The variability of its pitch allows it to have the most efficient angle of incidence to the oncoming flow. Its rotor blades turn slowly when the tide is running. The system incorporates a self-leveling device which allows the rotor to face directly into the current. HS1000 tidal turbine was designed such that its nacelle can be removed from the supporting structure and taken away for maintenance. In February 2012, HS1000 delivered its first energy to the grid and continued operation for more than 17,000 hours. It produced over 1.5 gigawatts of electrical power during that time to the national grid, powering an equivalent of 250 households for a year. Using the knowledge and lessons gained from the prototype, Andritz Hydro Hammerfest developed 1.5 megawatt turbines. In 2014, the company received an order from Maygen Limited to supply 3 1.5 megawatt tidal turbines. The 3 turbines were later installed as part of the Maygen project. This Maygen project is planned to be the world's biggest tidal energy project. It will be developed in 3 phases. The first phase is subdivided into 3 subphases: Phase 1A, 1B, and 1C. Phase 1A was officially commissioned in April 2018. It involved the deployment of the 4 1.5 megawatt tidal turbines by Andritz. This resulted in an installed capacity of 6 megawatts. Phase 1B will add 4 more turbines and is expected to be completed by 2020. Phase 1C is expected to be completed by 2021 and will involve the installation of 49 turbines, which will bring the total capacity to 86 megawatts. This project is being developed on a 3.5 kilometer long stretch in Pentland Firth, which is located between the island of Stromagh and mainland Scotland. This site was identified in 2007 for tidal energy development. The area boasts of some of the fastest flowing waters flowing through a natural channel between the North Sea and the Atlantic Ocean. The first power from this project was delivered in November 2016. Since then, the first 4 turbines have been recovered for inspection and redeployed. The project is planned to increase in capacity to 252 megawatts and 398 megawatts, respectively, through Phase 2 and Phase 3. By the time the project is completed, it is expected to have generated enough clean power to power up to 175,000 Scottish households. According to a report by CIMEC Atlantis Energy, the project has been delivering its best operating results. Within the first 6 months of 2019, the pioneering project exported more than 21 gigawatts per hour of electricity to the national grid. It generated a revenue of 2 million euros, which is higher compared with 1.3 million euros in 2018. Tidal energy systems have been shown to be friendly to the local ecosystem. For example, a report on the Maygen project showed that seals, dolphins, and many other animals would avoid the tidal turbines. It was theorized that the avoidance would be due to the fast-flowing water and not as a result of the noise of the turbine. Also, a sonar detection system was tried on Maygen to track and potentially stop the turbines when large animals pass through the area. One major concern about the Maygen project is the potential use of toxic anti-fouling coatings to prevent marine growths on the turbines. The company in charge of the project was well aware of this. Instead of using the toxic anti-fouling coatings, they used low-friction paint, which will prevent marine growth due to the slippery nature of the paint. It is interesting to know that the Maygen project is just one small section of a larger 1,600 megawatt ocean energy project planned for execution at Pentland Firth in Orkney. If this larger project is well executed, it will go a long way to diversify Scotland's power. As time goes on and technology continues to advance, we will have more advanced tidal turbines at lower prices. Also, tidal systems promise to be environmentally friendly and won't cause too many disruptions to the aquatic ecosystem. We have enormous potential energy in the oceans waiting for us to harvest. The onus lies on us. Are you interested in learning more and improving your knowledge about our surroundings? This channel is dedicated to teaching people different topics about great phenomena and how they're being utilized to improve society. So, if you have not subscribed to my channel, do so now before you watch the next video. Also, click on the bell button too to be among the first people to see future updates on this channel. Thanks for watching, and never stop learning.